Welcome back to Upgrade to General, a series to help you upgrade your amateur radio license to General class. This episode is Subelement G7, Question Group B, about digital circuits, amplifiers, and oscillators. I'm your host, Ron Call, KE7CR. Let's start with the questions. The first question asks, what is the purpose of neutralizing an amplifier? And the answer is to eliminate self-oscillations. An amplifying circuit can be used as an oscillator as long as feedback is provided back into the amplifying stage. So it will oscillate the signal. So neutralizing an amplifier is done by having a feedback that is 180 degrees out of phase with the input so that it eliminates that oscillation. The next question is, which of these classes of amplifiers has the highest efficiency? And I'm not going to go into all the classes of amplifiers and advantages and disadvantages. But just remember, Class C has the highest efficiency. They only conduct less than half of the input signal, so they have high distortion, but Class C amplifiers have the highest efficiency. The next question is, which of the following describes the function of a two-input AND gate? AND gates are one of the logic gates, and the way it works is both inputs have to be on or high for the output to be high. So the answer is output is high only when both inputs are high. The next question asks, in a Class A amplifier, what percentage of the time does the amplifying device conduct? It conducts 100% of the time. The next question asks, how many states does a 3-bit binary counter have? In digital systems, we count in bits, which is a 1 or a 0, either an on or an off for the circuit. So if you think the first bit has two possible values, 0 or 1, the second bit has two possible values, also 0 or 1, and you combine those, there's 4 possible values. The third bit would have also two possible values, so it has a total of 3 bits, has 8 possible values. The math is 2 possible states with 3 positions, it's 2 to the third power, so 2 to the first is 2, 2 to the second is 4, and 2 to the third is 8. You can count up the possible ranges in a byte, just going from 2, 4, 8, 16, 32, 64, 128, 256. That's 8 positions for 8 bits in a byte. There are 256 possible states. In a 3-bit counter, there'd be 8 possible states. The next question is, what is a shift register? It's a clocked array of circuits that passes data in steps along the array. The next question is, which of the following are basic components of a sine wave oscillator? To create an oscillator, you can have an amplifier and then a feedback loop with a filter. So the answer here is a filter and an amplifier operating in a feedback loop. The next question, how is the efficiency of an RF power amplifier determined? The answer is divide the RF output power by the DC input power. Next question asks, what determines the frequency of an LC oscillator? L stands for inductance, C for capacitance, and LC circuit has both an inductor and a capacitor. Often we connect those together in what's called a tank circuit. So the answer to this question is the inductance and capacitance in the tank circuit. Next question, which of the following describes a linear amplifier? Linear means the output waveform mirrors the input waveform. So the answer is an amplifier in which the output preserves the input waveform. The last question, for which of the following modes is a Class C power stage appropriate for amplifying a modulated signal? Class C amplifiers have a lot of distortion. They only conduct a fraction of the input signal, usually less than 50%, so distortion's high, but the efficiency is also the highest. This type of amplifier is appropriate for both FM and CW, but not AM or single sideband. And the only correct answer choice in this question is FM. That's it for this question set. Thank you for joining me, and we look forward to you in the next episode. This is KE7CR 73.